Good afternoon, all the attendees and respected panelists. The biggest challenge every food processing industry faces today is the lack of advancement and innovation in its manufacturing practices. To bridge this upgradation gap, we at Neologic decided to present Emerging Food Tech webinar series where we will talk about cost-effective food automations, applications of top-notch machineries and technologies, current trends and future directions in food processing sector, and much more. In the fifth webinar of this series, today we will be talking about advanced heating, cooling, freezing solutions in the food processing industry. Few words about today's speaker, Mr. Sri Krishna Ozarkar. Born in middle-class family in Nashik, he completed his entire education in Pune by completing mechanical engineering from Pune University in 1987. After spending few years in SKF, he joined Alfa Laval and worked in project planning and execution in dairy and beverage sector of manufacturing department. He started his entrepreneurial journey by starting his own firm in 1996 and eventually merged his business areas with Neologic. He was instrumental in Neologic's partnership with Fenco Food Machinery Italy for fruits and vegetable processing machineries. Professionally a hardcore technocrat, chartered engineer and valuer, his interests are reading books and Indian classical music. Let me also introduce Mr. Yash Joshi from Intralox. Mr. Yash is working for Intralox since last 9.5 years and managing the food business like frozen fruits, fruits and vegetable, dairy and RTE segment for India and Southeast Asia. He's also handling Spiral platform business, which is one of the critical piece of equipment in the process line of the region. He has a decade of experience in working with various customers where he could significantly contribute by optimizing conveyance solutions, process automation, and improving efficiency with focus on food safety and hygiene. So ladies and gentlemen, let me present our first speaker today, Mr. Sri Krishna Ozarkar. Over to you, sir.
Thank you, Nikhil. Thank you all the attendees and panelists for this webinar in the Emerging Food Technologies by Neologic. So what we are going to cover today, the objectives and points for the discussion today. So every food technology or every food processing requires conditioning. So we are going to have a look at what is the conventional or what was the conventional conditioning solutions, how spirals came into picture and why spirals were developed, what is the technology behind spirals, what are its benefits, and how actually we can add profitability in our spiral technology by shifting from linear to spiral technology. We'll also have a look at areas of application, and we will be having a look at increasing productivity through direct drive systems, that is Intralox patented system. So let us first understand what is the conventional conditioning solutions. So when we say conditioning, it can be heating, it can be cooling, it can be proofing, or it can be chilling or freezing as well. And this can be for a naked or semi-naked product, means the product is directly conditioned, or it can be also in a packed condition. So in both the ways, it is possible to condition the product to achieve the desired properties and also to achieve the desired shelf life. So what we are going to cover in this particular webinar is the industries which will be related to this particular technology. So this slide is basically to understand how you can relate your industry for spiral technology. So it can be any of these. It can be from milk industry, it can be from ice cream or meat, poultry, seafood, fruits and vegetables, bakery, personal care, ready to eat, or prepared food, or curd. So all this can be part of your industry or you're part of this industry. And let's see how we can actually add value or have more profitability by shifting over to spiral technology. So let us first have a look at what is spiral technology, because some of you already know spiral technology. Some of you may not be knowing. So let's just have a look at the spiral technology. So it's a half a minute or 0.75 minutes video, and we'll try to have a look at that. So this is the inlet of the spiral. This particular pouches you see is typically used for cooling of baby food products. Here you can see the spray happening on the pouches of those coolers, which are typically hot filled. Here you can see the spray pattern on the pouches. You can see the inside drum. Again, view from the outside. And this is coming out from the spiral. So this can be for any pouches. This can be for any direct products such as cakes, bakery products, in which case, instead of water, they will be using air. So this is just for the understanding of all the people who are attending this webinar. So what was used when the spirals were not there? So when the spirals were not there, we have a typical what we call as a linear tunnel. And this linear tunnel was normally occupying a lot of space in the processing hall. So as I mentioned earlier, the food products undergo heating, holding, proofing, cooling, freezing as a parts of your process to achieve the desired properties or to achieve the shelf life. And again, as I mentioned, it can be for direct products or it can be for the semi-packed or packed products. So these linear tunnels can be linear freezers or linear tunnels using water or linear tunnels using chilled air. So this is a typical example of two tunnels, the photographs of two tunnels. You can see they are occupying a large space on the processing area, which is also rare in this in our processing hall. So this typical photograph you see on the top side is actually occupying 2.5 meters by 22 meters or 23 meters space just to process 2 tons of filled product, hot filled product to cool it to a certain temperature. Similarly, what you can see at the bottom is another tunnel, linear tunnel with a lot of motors, a lot of pumps and other things. So this was a typical example of what was happening conventionally over the years. As I mentioned, 2.5 by 23 meters space. Power consumptions in linear tunnels were quite higher. We saw in the earlier picture, number of motors being used, the amount of torque developed in particular linear tunnels was very high. And this was leading to higher operational cost. So this is how people came up with the solution of spirals. So let us understand why spirals, what is the technology, benefits, and adding profitability. So the development of spirals actually started in late 60s as an alternative solution for the linear tunnels. And now this is widely used in food and non-food industries. It started with the structure supported systems and then evolved into self-stacking mechanism and remained unchanged. And it can be friction driven or tension driven overdrive systems. And the direct drive patented system introduced by Interlocks came into picture in 2012, which eliminated most of the challenges associated with the friction and tension driven systems. And we'll understand this in detail from Mr. Yash. Again, as I mentioned in earlier slide, the principles of operation can be friction drive or tension drive or what we call as an overdrive. And these can be structure supported or this can be self-stacking spirals. In direct drive system, it can be again structure supported or self-stacking. We'll understand in detail what is direct drive in coming time. Okay, so let us first understand the benefits of spiral conditioning solutions. So as I mentioned in the initial slides, energy efficient, the amount of energy or the power required to drive my conveyor, which could be 200, 300 meters, in case of spiral is very low in comparison with the linear long tunnels. So that energy efficiency, actually I'm saving the energy and every energy unit saved is my every unit or every rupee earned. So this is very important in these days that we save energy. Second aspect is leaving smaller footprint. As I mentioned, the typical 2-ton tunnel was occupying around 2.5 meters to 23 meters, and the same amount of cooling can happen, say in 4 by 4 or 5 by 5 meter square, in which the spiral can be working vertically. So what we are using is the number of tiers. So actually we are using the vertical space instead of using horizontal or longitudinal space. So I'm occupying that 300 meters of bed in that vertical space by using the vertical tiers, and thereby reducing my footprint on the process hall. Low water consumption, the water which is falling in the spiral, or it can be air, it can be water, or it can be other media as well. So the water consumption is less in spirals because I'm using spray patterns on all the tiers. The top tiers spray after falling on the pouch will be coming down on the tier below that. So in fact, if I'm having 15 tier spiral, the top one will be actually, the water will be contacting all the tiers or all the pouches. So thereby I require less water in comparison with the horizontal or linear tunnel. Low maintenance, of course, the technology is so beautiful that it requires low maintenance, accessibility to gearbox motor, accessibility to main drive, accessibility to the pump, which are all outside the system, is very good. And that is how we have low maintenance cost in this. Operational cost efficiency, as we require less torque and less energy or less power motor, then my operational cost goes down. We'll see the example of that when Yash is talking about that. And last and foremost important, again, in this particular aspect, is flexibility in inlet and outlet orientation. As we know, spiral is a round or is a full circle. We can have different orientations like you see. So top inlet, bottom outlet, or top inlet, top outlet, and it can be 180 degrees, it can be 90 degrees, it can be 360 degrees. So there can be a perfect combination depending on my process hall layout. In a linear tunnel, I need to have exactly 180 degree orientation, inlet from 180 one side and exactly 180 degrees outlet. But in spiral, I can actually adjust based on my layout of the machinery in the process hall. I can actually adjust the inlet and outlet. So this is the first and foremost aspect of having the flexibility. Apart from lesser footprint, this is also going to give me flexibility of inlet and outlet. And let's see the areas of application. Of course, spirals can be spiral freezers. Spirals can be refrigerated coolers. Spirals can be ambient coolers. When we say ambient coolers, it is cooled by ambient air. And spirals can be proofers, where we require to maintain the humidity. Then it can be pasteurizers. So when we say pasteurizers, it is actually heating and cooling. So the picture you see right now on this particular slide, on the left-hand side is a spiral which is heating the hot-filled pouches, and on the right-hand side, it is cooling the hot-filled pouches. So it works like a pasteurizer. Then it can be only heaters. So some applications require only heating, and it can be hot holders. So I have hot filled a particular pouch with a curry or with a ketchup or sauce, and I need to hot hold it for a certain number of seconds or certain number of minutes. So that application is also possible in spiral. Again, we go back to the first slide, industry-wise. We have a lot of applications in food processing industry. In dairy, we have cheese, paneer, curd, and ice cream. Again, cooling of all these atoms during their process, which is very important aspect. And not only this is hygienic, but this is also less power consuming, and this is faster. This is a continuous process. Ice cream hardening tunnels, linear tunnels. Again, we are shifting to spiral hardening tunnels. It can be for cones, it can be for cups, or it can be for bulk packs or family packs as well. Meat, poultry, seafood, and fruit and vegetable division, so that all these atoms can be actually spirally frozen to get their temperature. It can be -18, -20, or whatever you want. Bakery atoms, so it can be bread, it can be rusk, it can be cakes. So all bakery items actually are using spirals for cooling of this technology or cooling of their products. Curd, again, cooling of the curd. Ketchup, sauces, these are typical example again for the pouches, or even it can be for bottles or cans and other things as well. Ready to eat, this is the fastest growing segment these days, and all ready to eat items filled in a pouch are typically cooled on a spiral cooler. And then we also have certain applications in non-food, that is personal care like soaps and other areas. Again, some of the areas of applications. So it can cool fried products as well. So typically we know that all namkeen items are fried. They reach temperature of 170 to 180 degrees, and these need to be cooled to room temperature or 35 degrees before they are being packed. And that needs to be cooled in a certain way because we need to achieve certain crispiness, certain softness, core softness for the product. So that is typically done on the spirals. Again, as I mentioned, bakery products, it can be bread, it can be rusk, it can be also all the cakes and biscuits and other items. Hot fill pulps, all purees like mango puree, guava puree, or other purees are also hot filled. Baby food items or baby food, different varieties are hot filled. Sauces, ketchups, curries, gravies, and as I mentioned earlier, RTE items. So it can be paneer butter masala, it can be dal tadka or anything. Batter cooling, this is another application where we need to maintain the temperature of batter, which is filled inside the pouch. If the temperature goes beyond a certain dedicated temperature, then batter starts fermenting. So we have to cool it and keep it under, say, refrigeration. Dairy products like paneer, cheese, ice cream, cooling and hardening or freezing. And as I mentioned, meat, fish, poultry items. So the areas are numerous. So let us first understand some of the technical aspects, which are not very technical, but it's a part of technicalities of the spirals. So as I mentioned, the flexibility in the configuration. Here you can see some of the layouts based on the customer requirement, entry from bottom and exit from top from the or the bottom again as required from the other side. And then there is another example of using two spirals where entry can be from bottom going on the top, shifting to another spiral at the top, and again coming down. So one spiral going from bottom to top, another spiral going from top to bottom. So this again is customized. There is nothing standard as such because every solution is customized in spirals. This is a typical construction of a spiral. This example you see is the hardening tunnel for ice cream, where you can see the drum and you can see the tiers of the spiral. You can see the evaporator coils for the hardening tunnel. So this is, then there are the recirculation fans inside the tunnel. So this again is designed based on the customer requirement. The belt circuit, the belt for all the spirals is always continuous. The point which is entering is also exiting and it is coming again to the same point. And since it is a modular belt, you can adjust and you can just join it anywhere as required based on the length of the particular tiers. Then this is a typical drawing of the drum. We'll not go into technicalities of this. This is just to understand that there is a bearing housing on the top and bottom, which is maintaining my concentricity of the spiral so that spiral doesn't move haywire. Why it is important? Because when I'm keeping any product on the spiral, it should not move from its place. So my spiral should be perfectly balanced. It should be moving very smoothly without any vibrations or without moving the product which is kept on the belt. This is a typical arrangement of the tensioning. Again, as I mentioned, we will not go into the technical details just to understand, because the belts undergo elongation over a certain period and that is self-adjustable. This is what we call as a tensioning motor, and this is in always tandem with the main motor or main drive, so that both are working together to adjust their speed or adjust the torque which is getting developed on the particular belt. We also have washing systems, so it can be washing for the entire drum or the entire inside, and there is a separate system for washing of the belt. So let's see some of the spirals in action. Here you can see a spiral, which is a spiral pasteurizer. On the foreground or on the behind is a spiral which is heating the particular pouches with hot water. What you see in the foreground is a typical spiral for the cooling application. And then you see two dryers, which are inline dryers with 4 turbo turbine blowers on the top, and also a lot of nozzles to take out the excess water from the pouches, because these pouches are water cooled. So all the excess water which is coming on that needs to be removed, taken back. You can also see the heating system or cooling system. In this application, it was for cooling. So it can be using either cooling tower water or it can be using chilled water. Then we have a pump with the filter. So the whole water is again recirculated and re-chilled based on the application. This is the same spiral again with the other view. As I mentioned, on the left-hand side, you can see the control system for hot water. And on the right-hand side is the system for chilled water or cooling tower water. Entry for the left-hand side, heating is at the bottom, exit is at the top. This top becomes the entry point for the second spiral, and again the exit at the bottom. So this is typically used for hot filled pouches. It can be sauces, it can be curries, or it can be ready to eat items. Now this typical example of products having different retention time. So I can be hardening, or I can be cooling or freezing, say cups and cones, or I can be doing it family packs, or I can be doing party packs. And all these products, depending on their volume, require different retention time. So we have different exits for different products in this particular case. This is another spiral in action, again for hot filled pouches for curries, RTE items, and ketchups and sauces. You can see top motor again accessible, and then you have pump and inlet at the bottom with the blue belt. The exit is at the top. You are not able to see the exit in this particular picture because the spiral is hiding that exit, which is a declining conveyor. Again, the same spiral with the view. What you see in the forefront is where my arrow is or cursor is a typical divider aligner. So my filling machine is actually filling one pouch at a time, but I am dividing it into 1 by 3. So I'm utilizing the belt space, and then I'm putting 3 pouches on one conveyor or in one line and then going ahead. So this can be 1 by 3, 1 by 2, 1 by 4, or 2 by 3, depending on the configuration. So this is perfectly designed to suit the customer requirement. So what you see over here is the entry of the spiral. Ice cream, as we mentioned, it can be used for cones, cups, and party packs or family packs. This is a typical example of ice cream cones. Another example of ice cream cones being hardened after they are being filled at around 4 degrees or -4 degrees. Another application, again, as I was mentioning, atoms which are fried need ambient air cooling, and these are typical usage for namkeen atoms. The spiral you see over here is a typical example for use for bakarwadi, but on the same spiral they are using shave and other items from which are coming from the fried area. So it can be also used for samosa. And let's understand how we can actually increase the productivity through interlocks direct drive system. So over to you, Yash.
Thank you, Zakir sir. Thanks, Zakir sir and the team. It was a very insightful discussion about the spirals. So what we will do today is we'll share some of our experience in the industry in India, what we have learned, and what values we could bring in terms of overall improving the productivity with our customers. So when they change from a batch process to a continuous process using spirals, yeah. So as mentioned by Ozarkar sir, there are various ways you can condition your product. So and there are multiple products can be done. So you have samosas, you have patties, you have product say in the pouches, product on the direct contact surface. So there is a variety of the products which we can consider here. But how do you normally condition is one way is mentioned is tunnel, the other could be blast freezers. So how a spiral is different than these two systems? And a question is why we want to use spirals. So some of the things which we have learned from the industry, if since last so many years of experience, batch process has certain limitations. So what are those limitations? Is one is a product quality and the consistency. So what happens is in a batch process, if your product is coming out of a cooker or a fryer or maybe from the oven, so before it goes to a conditioning, whether it could be freezing, cooling, any next step as a conditioning, it has to wait. Where does it wait, or the whole area is it has to, all the products need to be stacked in trays in trolleys. And once the trolleys are filled, they get into the blast freezer. So there is a lot of time which is lost, or product is just keeping idle before it moves to the next step. Second thing we have learned is also long cycle times. So generally we have seen blast freezers batch process has a considerably long time. Roughly we have seen 3 to 4 hours of batch process versus 45 minutes to an hour for a spiral. Obviously, it again matters with the product you're freezing, the temperatures you're managing, and the throughput you're doing. But generally, as a thumb rule, this is what we have seen. The third challenge we have also seen is floor space. So the layout generally is very tidy or messy because there is so much of trolley movement happening inside the plant, and it comes with its own challenges. The challenge is like once you have trolley, you have an unskilled labor getting in your high hygiene area. So a lot of trolley movement happening. You're missing on first in, first out. These are the typical challenges we have seen. And coming to the food safety now, it's becoming a big area of focus for the industry in India. For the reasons, A, we are trying to export. Second, the COVID, we have learned a lot. So conventional things are changing. And obviously the FSSAI and other norms are getting more stringent. So the food safety again becomes an interesting aspect when you're looking at a batch process. So what a spiral can do, so a spiral can eliminate all of these challenges. How? A, your product, your entire process you're making more continuous. So it's a more organized layout. The product coming out of a cooker, fryer, or maybe from the oven, it doesn't have to have weight. It just gets into your next conditioning process. So it reaches faster. How does that matter? Is biggest impact is we have seen in the product quality and the consistency. Because if the product is waiting or it's more ideal before it reaches the next step. So some things, drip losses, the crystallization, the rejection due to all those aspects we have seen happening. But with spiral, you avoid all those factors. The third biggest advantage is obviously the higher productivity because your cycle times are dramatically shortened. So imagine all the trolleys moving, then holding time, then the time required to freeze your product or condition your product is around 3 hours, 4 hours, depending on what we are doing. But here it's like we have seen 45 minutes max, 1 hour max, you're done with the product. The another advantage of this is your trolleys. So now we are eliminating the entire trolley movement in the plant and hence no unskilled labor getting into the high hygiene zone. And organized floor space is an indirect benefit you're getting. So what does all these parameters mean is directly, productivity goes up, the product quality goes up, the consistency comes in, and more organized layouts. So it directly increases, we have seen the profitability and of course the food safety. So all these parameters we have seen, and we also have some of the live case studies which I'll share in a moment. So it's not just we are saying, but we are seeing is, it's directly money saving when you go with the technologies like this. Also, Ozarkar sir has mentioned about direct drive. So in the previous slides, we have discussed, a conventional way of running spiral. So few years, 60 years back, the technology was developed. Initial technology, or it's still being used, is friction driven spiral. So what is a friction driven spiral? You have a lot of tension between your drum and the belt. So I'll show a video which you can see on the screen. So your left side is a friction driven spiral. What we see is a drum is rotating at a faster speed than the belt, and you're managing the two different speeds. So your drum speed and your belt speed, and the differential of these two speed is called as overdrive. So there's a constant synchronization happening between the two speeds. Now, from the customer perspective, how does it matter to you? The spiral is working. So when it starts affecting is when you are producing samosas, or you're producing, cooling products like bakery, which has a lot of fat content in it. So the fat starts depositing between the drum and the belt area. So the moment you have the fat, grease, different kind of product loadings coming in place, so your tension parameters, friction parameters goes haywire. And then there is a constant struggle in managing the or synchronization of these two speeds. So generally we have seen what you're producing at an hour, first hour of the shift versus, at the end of the shift. There is a lot of controls need to be managed in a friction driven spiral. If you look at a direct drive, it's a very simple technological advancement. What it does, your drum and the belt running at a same speed. Why that happens? If you see on your left, you can see a gear and teeth kind of mechanism. So your drum is what is represented here with white carriway or the white cage bar, and the belt is engaging. So you're engaging like a gear and teeth to your spiral. When you do that, you are positively driving the spiral. So the tension component is completely gone out of your system, which means you don't need overdrive. You are not managing the differential speeds in the system. And it's a direct benefit. Your spiral is not going to flip. It is a reliable system in terms of performance. So what you're producing on the first hour of your shift will be producing at the last hour of the shift. And it's no maintenance system because there is no overdrive, there is no excess wear and tear of the system. And these are the direct benefits what we have seen with the direct drive system. So let me show some of the case studies we have done with our customers. So here is an example. So we have worked with one of our customers in India who's producing the frozen products. So there are 4 major contributors we have studied here, which had resulted in the overall payback and the savings. So one is when you're freezing a product, earlier they were using blast freezers and moved towards these spirals. So when you're freezing a product in a blast freezer, there has to be you have to measure the counter, or basically you have to counter the drip losses, because blast freezer, that's very common phenomena we have seen. So you have to add little more grammage in the product. So if you're producing 100 grams, probably, you have to add another 5 to 6 grams more of the product. The second contributor we have seen is the damages due to crystallization. Some of the shells get damaged. So all those damages cause contributing a rejection of around 2%. So these are the actual numbers what we have learned from the customer. And the third major contributor is the labor, because the entire trolley movement is gone. A lot of packaging labor is optimized. And the fourth contributor is inconsistency with the blast freezers. So all those put together, we have seen roughly around, it's not a large capacity. It's even if it's as small as 400 to 500 kg per hour line, we were able to save almost 31 lakhs per annum. And if you have an investment, then it's around less than 3 years, so 2 years and 7 months is a payback when you're investing into a spiral. So this kind of dramatic improvement. So it is a money saved, but on the other hand, we are getting the benefits of your productivity, overall the quality and consistency. Another example I'll quickly run through is we have studied with the help of Neologic here. So when you're comparing, tunnel versus spiral, so what difference does it make? So generally, if you're running a 6,000 kg per hour line, and if you want to compare tunnel versus, the spiral cooler, we are not even comparing the space saving and all those factors here. That's again a huge. But importantly, if you're just purely comparing, how the operational cost, the maintenance cost, all those things coming in would matter. So roughly 15 paisa per kg is saved when you're using a spiral cooler versus a tunnel. This sounds little 15 paisa. It's like, okay, it's just the 15 paisa. But when you are, comparing it, or when you're adding 6,000 kg per hour as a product which you're producing per hour, even it's 20 hours a shift, 6 days a week, that contributes to 51 lakhs, almost 52 lakhs of saving per annum. So that kind of numbers we have seen, and based on our experience with the end users. So these are the few things which we wanted to share. I think over to you, Ozarkar sir, please.
Thank you, Yash. It was actually a fantastic figures, and these are actual facts which have been shared by our customers
Yes.
along with Interlocks. We have done the study, and this particular has been observed with that.
Yes.
We just went through how we can actually increase the productivity or increase profitability by using Interlocks direct drive by Yash. Let us take a recap of what we actually went through, and then we can be going for the question and answer session. We understood what is conventional conditioning systems, how much space they were occupying, whatever the limitations, why they were using more energy. We also understood what is spiral, how spiral technology is using vertical space by building tiers one above the other, thereby saving the linear space or horizontal space. What are different technologies, whether it is overdrive, whether it is a direct drive, all this that we have just understood. We also went through the benefits, all the benefits apart from space saving, energy saving, the flexibility in terms of inlet and outlet. So all that we have gone through. And we also understood how we can actually add profitability by using spiral technology and especially direct drive. We also understood areas of applications, different applications. We went through different industries, and it can be for all the dairy, or it can be for meat, poultry, or it can be also for fried items. So that we have understood. And lastly, we also understood what is the amount of saving which we can achieve by using direct drive system. So these were typical points we have covered. Of course, this was a general presentation meant for everyone. We can have one-to-one discussion on what actually they want based on the customer feedback and other things, because as I said, everything is custom built or custom designed. So now I hand over to Manu for the question answer session. Manu, you can start picking up the questions. I think they are in both chat box as well as.
Yes. Yeah, we actually got a number of very interesting questions. Can you hear me clearly?
Yes, we can hear you clearly.
Okay, yeah, we got a number of interesting questions. I just want to assure the audience, if we don't get to your question during this session, we will reach out to you either by email or directly at your registered phone number to let you know the information. In case you have any other questions that come up in the future, please feel free to reach out on this information that has been provided either by phone or by email, and we'd be very happy to answer your questions. The first question is, what are the, we saw the names Neologic and Intralox, but what are the areas of expertise of these two companies?
Okay. So when you saw the names of Neologic and Interlocks, these are two big companies who are masters in their own field. So what Neologic does, so Neologic is basically into processing technology, and it can be for any food application. So it can be for dairy or dairy byproducts. It can be fruit juices, pulse, carbonated beverages, ready to eat items. So all kind of food processing. We are also into pharma, as you can see, the complete care of process and automation for different sectors, what you can see on the screen. So these are typical areas of expertise of Neologic, basically into processing. We can say our core strength is engineering with processing. And of course, Yash, I'd like you to take over for expertise of Interlocks.
Sure, thank you. It's a good question. So, Introlox, we are a US-based company, and if you look at our background, this year we are celebrating 50 years in this world. So, we are market leaders when it comes to conveying solutions. What we did 50 years back is just the invention of a modular belt in the world. So, that's how we started. Then, from that onwards, the journey began, and we had now more than 1,500 plus active patents with us. So what we do as a company in a very broad way, if I have to explain, we handle two areas of your plant. One is a process side and second is the end of line side. So process side, where your direct food contact applications, you have certain critical pieces of equipment. You have blanchers, coolers, spirals, IQFs. So all those come in place where, it's like a mission critical equipment. One, second, you're moving your direct food contact, direct application. So where your food safety, hygiene is important. So we, considering all that, we design conveyance and we give you the solution. The second part is the end of line side. So once the product is packed, it's in the carton, it's in the pack. It has to be moved from your production area to the packaging side, then from packaging to the palletizing, all those factors. So entire layout optimizations, conveyance in that part, sortation, automatic sorting, switching, all those applications have been done. So this is broadly what we do as a company.
And in this case specifically, Yash, also with the spiral equipment, Interlocks is the inventor of the direct drive technology that Mr. Ozurkar talked about as well. Is that right?
Yes, thanks.
Great. Great. I'll keep this moving just because we have quite a few questions. The next question, there were a couple of questions about the industry, specifically about dairy, right? So the questioners were Mr. Balaya and Mr. Kishore Endukuri. Number one, can we use in fresh milk process? Number two, can you provide examples of implementation in paneer and yogurt or curd?
Okay. So basically, we are not using this technology for liquid milk. We are, of course, using it as a part of cooling for paneer or cheese. So that is a part of the process which we need to cool cheese or paneer or curd to a particular temperature. And so, of course, we can take your numbers and we can have detailed discussion on this because this involves a certain technical aspects which we need to explain. But as I mentioned, we are not doing this for liquid milk processing.
Great. And we have several installations with paneer out in the fields working very well. Isn't that right, Mr. Ozurkar?
Yes, yes. Typically for paneer and cheese, there are a lot of installations.
Yes, great. Okay, there were quite a few questions with regard to cleaning of the system or cleaning of the spiral. Mr. Biswajit Acharya, Mr. Balaya, Mr. Binod Kafle, they all asked about how do you clean the system, especially with a product that is not fully packed on all sides.
Okay. So very good question and a very important question because this is the main problem which most of the process industries can be facing. So as I covered in earlier slides, so we have two types of cleaning systems. One is for cleaning of the entire drum on the assembly, and second is for the belt. So as I mentioned, the belt is always a continuous one. So what is entering is again going back. So at the point where the belt is going on a return path, we actually install a separate washing system. So when the bolt is going like this or going like this and coming back, I have a separate station or separate container or enclosure where I can have spray nozzles which are going to spray on that particular belt portion, which can be number of nozzles depending on the belt width. And then this washed water is collected back in the tank at the bottom. It is filtered and again recirculated. The belt which is going ahead on the return path, because it has been washed with the water, also needs to be removed from excess water. So we also have a turbine blower along with air knives and air nozzles to take out the excess water from the belt. Because if I got product like bakarwadi or samosa, the belt which is already wet with the washed this thing, it will get damaged my product. So these are again clean, or the excess water is removed by the air nozzles, air knives, all this. I hope this answers your questions. Of course, as I said, there is a separate slides or separate technology for cleaning of the belt, cleaning of the entire system, and we can discuss it offline.
Great. Thank you, Mr. Ozarkar. There's a question from Mr. Charles Michael about what is the maintenance cost like with this kind of system, and how does it compare with others?
Yeah. Okay. So basically, as we told you, or as we covered in the earlier slides, the torque requirement or the power requirement in spirals is less because the tension is less as compared to the linear tunnel. And again, the accessibility to the main drive or accessibility to the tensioning drive is far better in comparison with the linear tunnels where we have motors at the bottom side or pumps at the bottom side. And again, if I to put some belt modules or some pieces of the belt in a modular system, it is difficult because the accessibility in linear tunnels is less. So coming back to your question, in comparison with the linear tunnel, this is quite low. Normally, providers like us or even Intrologs, we have AMC systems. So we have annual maintenance contract, which is of very nominal charges. Idea is that our expert people can actually cover all the aspects of running, whether the system is running in perfect tandem or not, whether the basic care is taken while running or not, because the operators are trained for the process. They're not trained or they are not fully expert in terms of running of the machine. So here what we do is we ask our customer to take our AMC, where we can actually provide monthly or quarterly visit depending on the configuration of the particular project.
Great. Thank you. The next question, this is from Mr. Biswajit Acharya. You mentioned in your presentation about less energy consumption with spirals. Is it possible for you to try and quantify that, and how much lower is it than the conventional systems?
Okay. So just to give you an example, last week we were in discussions with one of the customer for this particular aspect only, and the linear tunnel was actually engaging 58 kW and we were engaging 35 kW. I'm talking about total power requirement for that particular application. I'm not going into detail of the name the customer. So the saving of 13 kW every hour into 20 hours and into number of days, because this particular industry runs for almost 350 days or 360 days throughout the year. So that much amount of saving. So depending on what particular application is, we can actually quantify how much energy we can save or how much this budget saving can be happening in our case.
Great. We have time for a couple more. Mr. Aram Khan asked a question about the applications for this technology for spirals in the bakery industry.
Yes. So like I said, bakery, typical extension. Yes, you want to take over for this question?
Sure. So in bakery, we can do spiral. Generally, they are used for proving application. You also have cooling. These are major areas of application, and some cases we are seeing customers also using freezing. So that application also we have been using. And in India, we are covering most of the bakeries, customers like Britannia's, Mongeries, such multiple bakeries. We have our installation.
Great. Yash, we'll stay with you. Mr. Deepak Mehta wanted to understand a little bit better what is the explanation of the concept of overdrive in practical terms.
Okay. So, Mr. Mehta, the overdrive is nothing but what you are doing is synchronization of two speeds. So in a friction-driven system, you're fundamentally driving with a lot of tension in the belt and the drum. So this is your drum, and you're putting a lot of tension in the belt, and then you're driving. That's one. So what happens is your drum has a separate speed. Drum is generally rotating at a faster speed than the belt. So you have two differentials of speed, which you have to synchronize in your friction-driven system. And that speed differential is called as overdrive, in a simple word. And hope this answers your question.
Yeah, if you could build on that, Yash. So how does direct drive overcome some of the issues with that overdrive concept that you talked about?
Yes. So as shown in the video, what direct drive does is our first principle is we eliminate the tension, and instead of friction driving your belt and the drum, we have the gear and teeth. So imagine your drum and the belt is engaging like a gear and teeth mechanism to your drum. So the moment you engage your system rather than friction and tension to take care, when you engage, run it positively. So your drum and the belt running at the same speed because you're engaging, you're driving it together. And that's how you eliminate the two speed differentials between the drum and the belt. And that is called as direct drive technology.
Great, great. Thank you, Yash. We have time for one.
Yeah.
I think we have time for one last question. This is for Mr. Rohit Ranalkar. It's a two-part question. You can answer them correctly together. Are all belts plastic? Number one, and are the spirals side-driven too, or are they all cage and drum type?
So very good question. So not all the belts are plastic. The conventional system which started 60 years back, you had seen a lot of metal belts also. And till date, certain fryer applications, certain specific applications where the temperatures are more than 150, 100 degree plus, you still have the metal belts used. But since all the metal belts are driven with the tension friction driven system, and two reasons why the metals are becoming less popular now. One, the overall system is very heavy when you use a metal belt. So roughly we are seeing 40% higher in the weight. That's one. Second, when you use a metal belt and you're driving in the friction tension mechanism, so however is whichever is the system, whether it's imported, domestic, whoever has built it, the metal belt will always flip because the overdrive parameters eventually give up. So little change in the tension controls, the metal belt will flip. That's another reason. So when it flips, the entire product is gone. And third is there's a lot of maintenance in the metal belt. You have the grease, oil coming, you have to constantly maintain that, which is not very product friendly and especially not very hygienic or food safety perspective. So that's why things are changing from metal to plastic. Hope this answers the part one. And the second part is Manu is about the whether it's a only drum driven system. So answer is no. As the technology has taken place, a lot of advancements have happened. So there is a drum driven spiral and there is a side drive where you don't have any drum in your system. So you have the shaft on which the sprocket is there and the belt is going to engage on the sprocket on the sides and then you drive the whole system. So that is very popular, not in the freezing applications, but that is used very commonly in the cooling applications or if you have a freezer and you have to generally freezer outfeeds are on the top and the product has to go down for packaging. In that case, decline conveyors are not always very space friendly or some of the products they start damaging. So you can use a side drive to bring your product down very delicately. So there's a lot of applications like that where you can use side drive as well.
Great, great.
Answers? Anything because you want to add, please feel free.
No, I think that you have answered it perfectly. Manu, we have time for a couple of questions if we have, because
sure.
We started at 4 or 5, so we can extend it for a couple of minutes.
Sure. Mr. Balaya is asking if we have further details on utilization of spiral in yogurt line, setting line.
Yes. So definitely that application can be explored. So Mr. Balaya, you can just mention your number and then our team will be getting in touch with you immediately post the session or maybe today evening or tomorrow.
Great. This next question is from Mr. Taqir Syed. You can answer in the way that is most comfortable for you, but can you share references of where your systems are installed?
Yeah. So we have almost more than 300 installations all over the world. So list is very big and it can be for different applications, like it can be for freezing, it can be for cooling from the fried items, again for cooling of hot filled pouches. So definitely we would like to get in touch with Mr. Takin, and then we will be sharing the customer list with him along with our definitely objectives.
I'll just add Krishna here. Neologic has a technological tie-up and manufacturing facility in India. Technology tie-up with company, Italian company. It's called Fenco. They are the one of the best manufacturers of the spiral technology, and they have the installations all over world, more than 300 or 500 installations in various applications.
And just to build on that, Interlocks has more than 3,500 plus spirals installed globally in different products. So right from proofing, freezing, cooling, hydro chillers. So multiple application base we have.
Great. I think one last question, and then maybe we can wrap it up. You had gone through the comparison between linear tunnels and spirals earlier on. I think you talked specifically about the energy, the difference in the energy consumption. Are you able to talk a little bit about the other differences in terms of what the customer will see in terms of costing, or what the user will see in terms of the expenditure between the two systems?
Okay. So again, the costing difference or the benefits on the cost or commercial aspect will depend on what kind of application we are using, what is the complexity of that, what kind of products we are processing. But typically we have observed that although the initial investment for the spiral technology is slightly higher, as Yash mentioned in his slides as well, or we also have data for number of customers. It is not more than, say, even 2 years or 3 years in most of the cases. So the break-even point is always achieved for that particular investment in 2 to 3 years, leaving apart all the other benefits of lesser footprint, then the flexibility in terms of inlet and outlet. So the kind of commercial advantage people will be getting is that particular investment is returned back in next maximum 2 to 3 years. If you really want to understand the comparison, we have to take certain product, and that product comparison can be different for different products. So for ice cream, it can be different. For the cooling of pouches, it can be different. So we would like to definitely take up one case and discuss with you in that particular aspect.